Next question we do is question number 9. Let's look at the question. The line joining the points A and B is divided by the point in the ratio 1 is to 5. So let's draw a rough line. That's my rough drawing. This is A, B. P divides it in the ratio 1 is to 5, but this is PB is to AB, which means part to total. So PB upon AB is equal to 1 upon 5. Now, if this is x, then this total is 5x, which means PA is equal to 4x. Therefore, PA is to PB will be equal to 4 is to 1. Notice that this has been given as part to total ratio. Now, we need to calculate the coordinates of P will be equal to m1x2 plus m2x1 upon m1 plus m2, and the y coordinate will be m1y2 plus m2y1 upon m1 plus m2. So let's look at this. M1 in this case is 4, x2 is negative 2, plus m2 is 1, x1 is negative 3 upon m1 plus m2, that's 4 plus 1. Next part, m1 is 4, y2 is 6, m2 is 1, y1 is negative 10 upon 4 plus 1. This will be equal to negative 8 minus 3, that's negative 11 upon 5, and this is 24 minus 10, which is 14 upon 5. We need to write our answer in the simplest form. Therefore, coordinates of P would be negative 2, 1 upon 5, comma 2, 4 upon 5. Perfect. Let's look at the next question. The next question that we do is question number 11. Let's look at the question. Question number 11 says, calculate the ratio in which the line joining these points is divided by the line x is equal to 2. So the points are given. These are the 2 points. Let's name them A and B, and the dividing line is x is equal to 2. So if this is x is equal to 2, let the point of intersection be P. This is negative 3, negative 1, and this is 5, 7. What would be the coordinates of this point? Since this line is x is equal to 2, which means the value of x will remain 2 and the value of y will keep changing. Let the point of intersection be 2, y. Done. Let's look at what do we need to calculate. We need to calculate the ratio and then the coordinates of the point. So I know that this point is 2, which means 2 is equal to m1 x2 plus m2 x1 upon m1 plus m2. Let's substitute. M1 we don't know, x2 in this case is 5, so this is m1 5 plus m2 we don't know, and x1 is negative 3 upon m1 plus m2, which we don't know. Let's cross multiply. So 2m1 plus 2m2 is equal to 5m1 minus 3m2. Let's take all m1 on one side and all m2 on one side. So this is 5m1 minus 2m1 is equal to 2m2 5 plus 3m2, which means 3m1 is equal to 5m2, which means m1 is to m2 is equal to 5 is to 3. Perfect. So that's my answer. Now they want me to calculate the coordinates of this point. Let this ratio is given. So I need to calculate the coordinate of y. So y will be equal to m1 y2 plus m2 y1 upon m1 plus m2. Let's substitute, which means y will be equal to m1 is 5, y2 is 7, plus m2 is 2, and y2 is negative 1 upon 5 plus 2. That 35 minus 2. 35 minus 2. Oh, this is not 2, this is 3. The m1 is to m2 is m5 is to 3. My mistake, I did not write it properly. So this is 5 is to 3. So this is 3 into negative 1. So this is 35 minus 3. That's 32. And again, this is 5 plus 3. So this is 8, which means y is equal to 4. Therefore, point of intersection is equal to 2 comma y, which means 2 comma 4. Let's look at the next question, question number 13. The point P 5, -4 divides the line segment AB as shown in the figure in the ratio 2 is to 5. So this is 2 parts, this is 5 parts. Now since this is intersecting on the x-axis, the coordinates of this would be x, 0, and since this is intersecting on the y-axis, the coordinates of this would be 0, y. So that's the most important part about this question. Let A be x 0 and B be 0, y. Done. Next part, find the coordinates of A and B given AP is smaller than BP. So AP obviously with a wave, that's why we've taken it as 2 is to 5. So I know P is equal to M1x2 plus M2x1 upon M1 plus M2. And similarly, the Y would be M1y2 plus M2y1 upon M1 plus M2. So in this case, 5, which is the x coordinate, is equal to m1. In this case, m1 we are taking as 2. So it will be 2 into x1, which is m2 into x2, m1 into x2. So m1 into x2 is 0 plus m2, which is 5 into x upon 2 plus 5. And y coordinate, which is -4, will be equal to m1, which is 2, multiplied with y2, which is y, plus m2, which is 5, multiplied with y1, which is 0, upon 2 plus 5. Let's multiply. So this is 7 into 5, 35 is equal to 5x. And this is -4 into 7, that's -28 is equal to 2y, which means x is equal to 7 and y is equal to -14. So what do we need to find? We need to find the coordinates of point A and B. Therefore, A is equal to 7, 0 and B is equal to 0, -14. Next question, question number 15. Let's look at it. Question 15 says, show that the line segment joining this point and this point is trisected by the coordinate axis. So let's look at, this is the rough line that I have. Let's name it A and B, -5, 8 and 10, -4. So we need to figure out that this is trisected by the coordinate axis. Let's find the points which trisected. Trisect would mean each part is equal. Each of these three parts is equal. Let these points be C and D. If I am looking at AC is to CB is 1 is to 2 and AD is to DB is equal to 2 is to 1. So let C and D trisect AB. Now let's try and find the coordinates of C and D. So C would be equal to m1x2 plus m2x1 upon m1 plus m2, and same for the y-axis, m1y2 plus m2y1 upon m1 plus m2. Let's look at let's substitute values. So m1 is 1, x2 in this case is 10, plus m2 is 2, and x1 is -5 upon 1 plus 2, and m1 is 1, y2 is -4, m2 is 2, and y1 is 8 upon 1 plus 2. This would be 10 minus 10 upon 3. This would be -4 plus 16 upon 3. So therefore C would be equal to 0, and that's 12 upon 3, 4. So coordinates of C are 0, 4. Does it lie on some axis? Yes, it lies on the y-axis. Now let's try and figure out the coordinates of D. So D would be equal to m1x2 plus m2x1 upon m1 plus m2, and the y coordinate would be m1y2 plus m2y1 upon m1 plus m2. Let's substitute values. In this case, m1 is 2 and x2 is 10 plus 1 multiplied with -5 upon 1 plus 2, and m1 is 2, y2 is -4 plus 1 multiplied with y1, which is 8 upon 1 plus 2. This is 10 minus 5, that's 5 upon 3, and this is negative 8 plus 8 upon 3. Therefore, D is equal to 1, 2 upon 3, comma 0. So D is 1, 2 upon 3, comma 0. So therefore, C lies on y-axis and D lies on x-axis. Therefore, the the line joining negative 5, 8 and 10, negative 4 is trisected by the coordinate axis. Perfect. Next question, question number 17. Let's look at the question. Question 17 says A is equal to something, B is equal to something, find the length of AB. So we've done distance formula in grade 9. Let's apply a distance formula to get the length of AB. So AB will be equal to x2 minus x1 whole square plus y2 minus y1 whole square, the square root of it. So in this case, x2 is 8. 8 minus of negative 4, that's 8 plus 4 whole square, plus y2 is negative 6 minus 3 whole square, the square root of everything, that's 12 square 144 plus negative 9 square 81, which means square root of 225. Therefore, AB is equal to 15 units. Writing this unit, very important. Let's look at part 2, the ratio in which AB is divided by the x-axis. So what are the points? Negative 4 comma 3 and 8 comma negative 6. So this is my line and this is my x-axis. This is negative 4 3 and this is 8 negative 6. So the ratio in which this divides, let the ratio be m1 is to m2. I need to figure out m1 is to m2. And what would be the coordinates of this point? The coordinates of this point would be x comma 0 because it lies on the x-axis. So let the point of intersection P be x comma 0. Now I know the y coordinate is 0, which means 0 is equal to m1 y2 plus m2 y1 upon m1 plus m2. Let's substitute values and find the value of ratio. So let's calculate 0 is equal to m1, not given, y2. So what's y2? Negative 6 plus m2 y1 is 3 upon m1 plus m2. Let's cross multiply. So I have 0 is equal to negative 6 m1 plus 3 m2, which means 6 m1 is equal to 3 m2, which means m1 is to m2 is equal to 3 is to 6, which means m1 is to m2 is equal to 1 is to 2. Perfect. That's my answer. Let's look at the question. It says in what ratio? So we figured out the ratio. Next question, question 19. Let's look at the question. It says ABC are the coordinates of the vertices of a triangle. P and Q are on these two sides and it divides, the ratio is 1 is to 2, which means this ratio is 1 is to 2. We need to find the coordinates of P and Q first. Perfect. So let's find P. P will be equal to m1x2 plus m2x1 upon m1 plus m2, and the y coordinate would be m1 y2 plus m2 y1 upon m1 plus m2. I hope you've noticed that I've been writing this formula for each question and each specific subpart, because I want you to remember that writing again and again helps you remember something. That is the only thing in this chapter. M1 x2. So m1 is 1, x2 is negative 1, plus m2 is 2, and x1 is 2 upon 1 plus 2. M1 is 1, y2 is 2, m2 is 2, and y1 is 5 upon 1 plus 2. This would be negative 1 plus 4, that's 3 upon 3, and this is 2 plus 10, that's 12 upon 3. So P would be equal to 1 comma 4. Done. We figured out the coordinate of P. Let's figure out the coordinate of Q as well. So Q again would be equal to m1x2 plus m2x1 upon m1 plus m2 and m1y2 plus m2y1 upon m1 plus m2. Right. So let's substitute values. M1 is 1 and x2 in this case is 5, m2 is 2 and x1 is 2 upon 3. This is m1 is 1, y2 is 8, m2 is 2 and y1 is 5 upon 3. So this is 5 plus 4, that's 9 upon 3, which means 3, and this is 8 plus 10, that's 18 upon 3, that's 6. So Q is equal to 3 comma 6 and P is equal to 1 comma 4. What's part 2? We need to prove that, or part 2 is to prove that PQ is equal to 1 by 3 BC, which means we will again have to find the length, again use distance formula. So PQ would be equal to y2 minus x2 minus x1, so that's 3 minus 1 whole square plus 6 minus 4 whole square, the square root of it. So this is 3 minus 1, that's 2 square, 4 plus 2 square, that's 4. So this is equal to square root 8, which is basically 2 root 2 units. Done. Let's try and figure out BC. BC would be equal to BC. So that's 5 minus minus 1, that's 5 plus 1 whole square plus 8 minus 2 whole square, the square root of it. This is 6 square, that's 36. This is 6 square, that's 36. So that's square root of 72, which means 9 into 8, that's that's 24. So that's 9 into 8, that's 9 into 4 into 2, right? That's 36, 72. So 3 into 2, 6, 6 root 2. Therefore, BC is equal to 3 times PQ, or PQ is equal to 1 by 3 BC. Done. Next question, question number 21. The line segment joining 2, 3 and 6, negative 5 is intercepted by the x-axis at point K. Write down the ordinate of the point K. Now, if you remember, ordinate is basically when you write first, the first thing which comes, which is your x-axis coordinate, is abscissa, and the y-axis coordinate is known as the ordinate. Now, since this is intersecting on the x-axis, which means the coordinate of the point will be x comma 0. So let K be x comma 0, right? So this is K is equal to x comma 0. So ordinate of K is 0, which is here. Next part, find the ratio. So we need to figure out the ratio. What's the first point? The first point is 2, 3. So x, we know 0 is given. So 0 is equal to m1 y2 plus m2 y1 upon m1 plus m2. Let's substitute. 0 is equal to m1 not given, y2 is negative 5 plus m2 not given, y1 is 3 upon m1 plus m2. Let's cross multiply. So 0 is equal to negative 5 m1 plus 3 m2, which means 5 m1 is equal to 3 m2, which means m1 is to m2 is equal to 3 is to 5, which means this part is 3 and this part is 5. Wonderful. Let's look at what else do we need to calculate. A good habit to highlight your answer, which means you should highlight this answer. The ratio is m1 is to m2 is 3 is to 5. Next, find the ratio, also find the point coordinates of the point K. So now that we know the ratio, let's substitute. X will be equal to m1 x2 plus m2 x1 upon m1 plus m2. Let's substitute. So this will be m1, in this case 3, multiplied with x2, which is 6, plus m2, which is 5, multiplied with x1, which is 2, upon 3 plus 5. So this is 18 plus 10 upon 8. That's 28 upon 8, which is 4 into 2, 4 into 7. Therefore, x is equal to 3, 1 by 2. We need to calculate x. No, we need to calculate the coordinate. Therefore, coordinates of k is equal to 3, 1 by 2, comma 0. Important thing to notice, any point on x-axis is given as x0 and any point on y-axis is given as 0, comma y. Next question, question number 23. Question 23, you can put a star on this question, a very interesting question. The line joining P and Q, so I've already drawn a rough diagram, P and Q intersects the y-axis at point R. Pn and Qn are perpendiculars from P and Q onto the x-axis. Perfect. Find the ratio of PR is to RQ, right? And then part 2, coordinates of R. Next, the area of the quadrilateral. Perfect. So let's look at this question. First, if it is intersecting at the y-axis, since this is the y-axis, what would be the coordinates? The coordinates would be 0, comma y. So let R be 0, comma y, because the x coordinate on this will always be 0. So first let's calculate the ratio. That's what they want. So 0 would be equal to m1 x2 plus m2 x1 upon m1 plus m2. This is m1 and this is m2, and this is x2 y2, this is x1 y1. Let's substitute. So 0 is equal to m1 x2 value is 3, m2 x1 value is -4 upon m1 plus m2. Let's cross multiply, which gives me 3m1 minus 4m2 is equal to 0, which means 3m1 is equal to 4m2, which means m1 is to m2 is equal to 4 is to 3. So that's the first part that they wanted, where they wanted the ratio. So this is m1 is to m2 is 4 is to 3. Done. Next part of the question says find the coordinates of the point R. So now let's substitute m1 and m2 in this equation, in the formula, which is y will be equal to m1 y2 plus m2 y1 upon m1 plus m2. Let's substitute. M1 is 4, y2 is 2, m2 is 3, and y1 is 5 upon 4 plus 3. That's 8 plus 15. That's 23 upon 7, which is 3, 2 upon 7. This is equal to y. Therefore, r is equal to 0, 3, 2 upon 7. So that's the value of, that's the coordinates of R. Now let's find the area of quadrilateral P, M, N, Q. So they want us to find the area of this quadrilateral. What does this look like? And since these two are 90 degrees, which means this line and this line are parallel to each other. So this is a trapezium. To find this, we will need to know their dimensions. Or what would point M be? Point M, since this is -4, this will be -4, 0. And n, since this is 3, the y coordinate obviously is 0, so this will be 3. Therefore, m is equal to -4, 0, and n is equal to 3, 0. Anything on the x-axis, the y coordinate would be 0, and this is perpendicular, which means this is -4 and this is 3. So now you can either count the distance between m and n, or you can use the distance formula. Whichever way you look at this, mn is equal to 7 units. This is 4 units on this side, this is 3 units on this side, which means the total distance is 7 units. So we know the height of this. If you remember, area of a trapezium is equal to half into height into sum of parallel sides. So I know half, now I figured out the height. Let me try and figure out the sum of parallel sides. So therefore MP, what would be the length of MP? MP is, this is 5 units. And what is NQ? NQ is 2 units, because this is 2 units up and this is 5 units up. Therefore, area of trapezium. This is trapezium PMNQ is equal to half into height. In this case, height is 5 multiplied with sum of parallel sides, which is 5 plus 2, which means half into 7, which means 49 upon 2, which means 24.5 square units. So interesting question, requires use of distance formula, requires use of section formula, and then requires you to remember what the area of a trapezium is. Perfect. Right. That's about it. Anything else in the question? No, we figured out the ratio, we figured out the coordinates of R, and we figured out the area. This brings me to the last two questions of this exercise. Let's look at this question. These are board questions, both of them came in the board. So in the given figure, APB meets the x-axis at A and y-axis at B. P is a point negative 4, 2, and it gives a ratio of 1:2. So this is AP is to PP is given as 1:2. Since A lies on the x-axis, the coordinates would be x, 0, and since B lies on the y-axis, the coordinates would be 0, y. So let's write this down. Let A be x, 0 and B be 0, y. Now, since we've been given this coordinates and we know that P can be calculated as m1x2 plus m2x1 upon m1 plus m2, this would be the coordinates of P, which is negative 4, 2, and the y coordinate would be m1 y2 plus m2 y1 upon m1 plus m2. So let's substitute values. This is the x coordinate, which means negative 4 will be equal to m1, in this case 1, x2 in this case 0, plus m2 in this case 2, x1 in this case x upon m1 plus m2, that's 1 plus 2. And the y coordinate here is 2, which will be equal to m1, which is 1, multiplied with y2, which is y, plus m2, which is 2, multiplied with y1, which is 0, and 1 plus 2. Let's cross multiply. This is negative 4 into 3, that's negative 12 is equal to 2x, and 2 into 3, that's 6 is equal to y, which means x is equal to negative 6 and y is equal to 6. So what do we have to calculate? We need to calculate the coordinates of A. So A would be equal to negative 6, 0, and B is equal to 0, 6. Anything else we need to calculate? No, that's about it. Simple question. In this case, the coordinates of the point were given. We needed to find the x and y coordinates of the line segment, which they were dividing in the ratio 1:2. Let's look at the last question. Given a line segment AB joining the points A and B, find the ratio in which AB is divided by the y-axis. So it intersects the y-axis of point. What would be the coordinates of the point where it intersects? Since it's on the y-axis, the coordinate would be 0, y. So let the point of intersection be 0, y. What do I have to calculate? The ratio. So 0 is given. So 0 is equal to m1x2 plus m2x1 upon m1 plus m2. Let's substitute. 0 is equal to m1, not given. A is given first. Yes, A is negative 4, 6. Perfect. So x2 in this case would be 8 plus m2, not given. X1 would be negative 4 upon m1 plus m2. Let's cross multiply. So this would be 0 is equal to 8 m1 minus 4 m2, which means 8 m1 is equal to 4 m2, which means m1 is to m2 is equal to 1:2. So this is the ratio in which it divides. That's part 1 done. Let's look at part 2. It says find the coordinates of the point of intersection. So I need to find the coordinates for this. I already know the x coordinate. Let me try and find the y coordinate. So y would be equal to m1 y2 plus m2 y1 upon m1 plus m2. Let's substitute values, which means y will be equal to m1, which is 1, y2, which is negative 3, plus m2, which is 2, y1, which is 6 upon 1 plus 2. Yes, Therefore, y will be equal to negative 3 plus 12 upon 3. Negative 3 plus 12 upon 3, which is 9 upon 3 is equal to 3. Therefore, coordinates of point of intersection is equal to 0, 3. Perfect. The last point, the length of AB. So again, we use distance formula. AB is, okay, so 8 minus negative 4, that's 8 plus 4 whole square, plus negative 3 minus 6 whole square, the square root of which, so this is equal to AB, which is equal to 144 12 square plus 9 square, that's 81, which means root of 225. Therefore, AB is equal to 15 units. Perfect. That finishes this exercise for us.